These are 64 raised to 1 by 2, then 32 raised to 1 by 5, then we have 125 raised to 1 by 3. See, so these problems are very simple, and before moving to the question solution, I'll little explain about this one. See here, square root of a, if we have, it can be written as a raised to 1 by 2. Yes, and square root of if we have 4, you can write this one as 4 raised to 1 by 2. Is it? In the same way, if we have 64 raised to 1 by 2, it can be written as square root of 64. Reverse. Okay, if we have a raised to 1 by 2, it is same as square root of 2. Yes, see here children, 1 upon 2 is not equal to square root of 2. Be careful. A raised to 1 by 2 is equal to square root of, this is square root of a. A raised to 1 by 2 is square root of a. You have a raised to 1 by 3 if it is, then it is called as cube. It can be done. It is same as cube root of a. Something like this one you have. So with this base, we'll try to solve these problems. First one is what? 64 raised to 1 by 2. See here how to solve this one. The first one is 64. We have here 64 raised to 1 by 2. As just now I explained, a raised to 1 by 2 can be written as square root of a. 64 raised to 1 by 2 can be written as square root of 64, which is equal to 8. This is one simple method, or you can do this way also. 64 can be written as 8 square and raised to 1 by 2 as it is. So further you have the indices laws. What they say here, a raised to m into a raised to n is equal to a raised to m plus n, and a raised to m raised to n can be written as a raised to m into n. Yes. So here what you are doing here, 8 raised to 2 into 1 by 2 here. They get cancelled, 2, 2. So you remain here with 8. The same solution, same answer you are going to get here. This way or that way. So these are very simple basic questions you have here. The second one is what? 32 raised to 1 by 5. See, fifth root of 32 is of no use. So what we'll do, we'll try to convert this we'll find the factors, okay, prime factors of this 32. And how it can be written in the form of this one here, how we have written 8 square. No, we'll try to find its factors. Okay, how? See, simple, by 2, common, very simple. Always try to take the prime numbers. 2 1s are, then 2 6s are 12, then 2 8s are, 2 4s are, 2 2s are, then 2 1s are. Is it? 32 can be written as 1 2 3 4 5. That is 5 times 2. That is 2 into 2 into, okay, this way 3 4 and the 5 times, or you can write this one as 2 raised to 5, not 1 upon 5. Yes, so what I am doing here, 32, I am finding the factors as usual, just I showed, and I am writing this one as 32 raised to 1 by 5 equals to 2 raised to 5 raised to 1 by 5. So you are going to, okay, see here 32 raised to 1 by 5. And you are going to write here a raised to m raised to n equal to a raised to m n. So this is equal to, we have here a raised to m into n, is it? So this 2 raised to 5 raised to 1 by 5 can be written as 2 raised to 5 into 1 by 5, is it? So this 5, this 5 and this 5 goes, and 2 raised to 1, that 2 raised to 1 is 2. One is what? Third one we have 125 raised to 1 by 3. Very simple. It is, you can write this one as cube root of 125. Yes, cube root of 125 you have studied in your 8th standard, which is equal to 5. Very simple. Or by using the laws of indices. So first of all, we are finding the factors of 125. Then here 5 2s are, 5 5s are, 5 5s are, then 5 1s are. Is it? So 125 can be written as 3 times 5. So I am writing here 125 equal to 5 into 5 into, so this is like this one, and raised to, what you are going to write here, this one as 1 by 3 as it is. Yes. Next what you are doing here, you are writing this one as 5 raised to 3, then you have here raised to 1 by 3. Very simple. So I am writing this one as this 5 raised to 3 into 1 upon 3. So it is good habit if you have this method of writing the solution as a raised to m raised to n is equal to a raised to mn. It will help you in understanding while solving the problems. Okay, so this is the beginning. Better to use the laws. Of course, you are using laws only. Better to mention the laws also what you are using here. Okay, this 3 and the 3 goes, and you are getting here 5 raised to 1, which is equal to 5. Yes, this is what the final answer of this third question. See this exercise 1.6 second question. They are similar to the first one. Here you have first one as 9 raised to 1 by 2, and the second one as 32 raised to 2 by 5, and the third one 16 raised to 1 by 4, and the last one is 125 raised to minus 1 by 3. Okay, these are similar to the first question. The difference is that one here, in the second one you have 2 upon 5, and in the last one you have minus. Wait, the power is with minus sign. The steps are similar. Okay, now I'll solve one by one. They are very simple. The first one is 9 raised to 1 by 2. Very simple. So as I explained the previous question also, we can solve this one in two ways. 9 raised to 1 by 2 is nothing but square root of 9, which is equals to 3. As I explained yesterday that square root of a is same as a raised to 1 by 2, or if you have a raised to 1 by 2, you can write it as square root of a. Is it? So in that way you are going to get this one, or you can go this way also. 9 raised to 1 by 2 is equals to 9 can be written as 3 square, and this one raised to 1 by 2. Okay, this is equal to 3 square into 1 by 2. This 2 and 2 get cancelled. 3 raised to 1, which is equal to 3. Okay, you are going to follow this one because these problems are given that one. The lesson or the concept is using the laws of indices. So you are doing those things. Next here, 32 raised to 2 by 5. Okay, what we'll do, we'll find the factors of this 32 first, then we'll simplify that one. See here, very simple. We'll take prime factorization of 32. Very simple it is. 32 by 2 we are taking here. 2 ones are. Then we have here 2 6s are 12, 2 8s are, 2 4s are, 2 2s are, then 2 1s are. So 32 can be written as 1 2 3 4 5. That is 2 to the power 5. Okay. So what I am doing here, I am writing this one. Second one, look at this one. 32 as 2 to the power 5, and we have raised to 2 by 5. So then raised to 2 by 5 as it is. Okay, now this is equal to 2 raised to 5 into this is 2 upon 5. Why it is? Because we have a raised to m raised to n equal to a raised to mn. Is it? So you are going to multiply these two. So here as usual this 5 and this 5 get cancelled. You are remaining with 2 square, which is equals to 4. Yes, now moving with the third one. Third one, what we have? Third one, 16 raised to 1 by 4. So what I will do here, I will first find the factors of the 16. See here, this can be written as 4 4s are, but we'll try to we'll convert this one as the to the factor of what? Prime numbers. Okay, that is in terms of prime numbers. We'll write this one here. 2 8s are, 2 4s are, 2 2s are, 2 1s are. Then 2 raised to 4 this is. Okay, 16 can be written as 2 raised to 4. Very simple concept. And raised to 1 by 4 we have here. This is 2 raised to 4 into 1 by 4. So if you want, it is better to write as a raised to m raised to n equals to a raised to mn. It is better. Wherever you are using the laws of indices, better to mention the law what you are using here. This 4 1s and the 4 1s goes here, and 2 raised to 1, which is equals to 2 you are going to get here. Okay. Now we have the fourth one. It is something like this one. 125 raised to minus 1 by 3. Sorry. 125 raised to minus 1 by 3. Okay. Now what we will do here? I will once again find the factors of this 125. That is simple as you know. 5 2s are 10. Then 2 remains. 5 5s are 25. Then 5 5s are, then 5 1s are. Simple. For all the problems, the same method we are following here. So that means 125 can be written as, say 3 times 5 is nothing but 5 raised to 3. Is it? So you are writing this one as 5 raised to 3 raised to minus 1 by 3. See children, here now next what we have here, 5 raised to 3 into minus 1 by 3. This 3 and this 3 get cancelled. Then you remain with 5 raised to 1, that is minus 1. See, a raised to minus 1 equals to 1 upon a. We have this one concept. The same way, if we have 2 raised to minus 1, it can be written as 1 upon 2. So 5 raised to minus 1 can be written as 1 upon 5. So this is the final answers. So these are the 4 sums which are very simple. You have to be a little careful while solving this minus. See what the mistake happens here. You may go with this way, 5 raised to 3 minus 1 by 3. If you go, then this way it is wrong. Okay. So you are not solving that way. It is a raised to m raised to n. It is a raised to mn. They get multiplied. Okay. So be careful, put into sign and solve this one in this way. Then you will get the correct answer. You have exercise 1.6, third one, simplify. The first one you have 2 raised to 2 by 3 and 2 raised to 1 by 5. And the next one is 1 upon 3 raised to 3 and the raised to 7. It is very simple. These problems are, the question looks more difficult. But these are very simple problems, children. And see, don't look at these numbers and don't get afraid what these powers 1 upon 2 and all those things. Very simple problems. These are already solved in your 8th standard. So if you have the basic idea, then it's good. Otherwise, see, I'll explain in short. You have suppose a raised to m into a raised to n is equal to a raised to m plus n. Often your teacher says this one. What is the meaning of this one? Suppose if you have two numbers with different powers. Yes, observe this one. The powers are different but the bases are same. Means suppose if you have a number 2 raised to 3 and 2 raised to 4. See, these are called the bases, is it? These two are same, bases are same and the powers are different. In that case, you can add what? The powers, something like this one. Okay, it doesn't mean that when if the powers are same we cannot add. See, you can add. Suppose if we have this way, then it's also 2 raised to 3 plus 3 this way. Okay, so these are the common what things often confuses you people. See, if it is 2 raised to 3 and 3 raised to 3, in this case this is not equal to 2 into 3 raised to 3 plus 3. Okay, main thing here what you have to observe is that the bases should be same. If the bases are same, whatever be the power you can add. Okay, see here, if it is okay, I'll not confuse you more here. I think this much is more than enough to explain, to solve the problem. So we'll solve one by one. First one, what we have, 2 raised to 2 by 3 into 2 raised to 1 by 5. Bases are same, we will add the powers. See how? I'll show one. Very simple. First one, what we have here, 2 raised to, you have 2 by 3, okay, into 2 raised to 1 by 5. So what I'm doing here, I'm adding the powers this way plus 1 by 5. See, we cannot add this way because these are fraction addition. This is fraction addition. You have to take the LCM of 3 and 5. Of course, it is 15. Directly I am doing here because you know that one, 3 and 5. 3 ones are, then 5 as it is, then 5 ones are, we do this one. Is it? So because of that one, what you are doing here, you are writing this one as 3 into 5, that is 15. Then 3 5s are, then 5 3s are. We are getting here. Then here 2 5s are 10. Very simple. You are multiplying this one plus. Is it? So this is equal to 2 raised to 13 upon 15 is the answer of the first one. Yes, next the second one is very simple. What you have here in the second one, 1 upon 3 raised to 3 raised to 7. Second one, very simple, children. See here, if we have a upon b raised to m, it can be written as a raised to m upon b raised to m. Yes, that I am writing here, I am using here. Okay, better if you write the property what you have used here, a raised to m into a raised to n is equal to a raised to m plus n property we have used here. Now I am using a by b raised to m is equal to a raised to m upon b raised to m. Okay, now look at this one. This one equals to 1 raised to 7 upon, here this is 3, already we have the power into 7. Yes, then what happens here? 1 raised to 7 is not 7, children. 1 raised to 7 means what? 1 raised to 7 means 1 is repeated how many times? 7 times. So if you multiply 1 into 1, 1 into 1, you're going to get this one as 1 only. So be careful with this one. Don't try. This is not equal to 7. Okay, this is 1. Now 3 raised to 7 3 is a 21. Very simple. Okay, next we have very simple. Next one, third one, what we have here? Third one is 11 raised to 1 by 2 and 11 raised to 1 by 4. What property we are using here? Here a upon b raised to m. It is what for the previous problem, a raised to m upon b raised to m. Now see the difference, a raised to m upon a raised to n. See, often you get confused, is equal to a raised to m minus n. What the difference here is? The bases are different here, but here the bases are same. In that case, you are subtracting the what? Powers. Remember this one. Often this one and this one confuses. So here what we are using? See the bases. What the base here it is? 11 and 11. Here the bases are different. 1 and 3. Is it? A by b raised to m. Now it is a upon a raised to m upon a raised to n. In this case, you are writing a raised to m minus n. So here for this type of question, I am solving even R.D. Sharma books problems, which will help you in understanding this one. And you need to practice, because if you are going for science in 11th standard, for that you need all these basic things perfect. Okay, and if you practice once or twice, if you spend 1 or 2 days with these things, you will become perfect, and often you will come across this type of power simplification. Okay, now look at this one. 11 raised to 1 by 2, 11 raised to 1 by 4 we have. So it is 11 raised to 1 by 2 minus 1 by 4. Powers are subtracting. Now here 11 raised to LCM of 2 and 4 is 4. You know, very simple. Okay, anyhow, for those students, those who are not perfect with LCM, 2 1 2 2 1 1. So what happens here? 2 into 2, it is 4. LCM is 4. Yes, that 4 I am writing here. 2 2 4, 4 1 4. 2 1 2 minus 1, which is equal to 11 raised to 1 upon 4. This is the final answer. Is it? And the last one, what we have, which is also very interesting, 7 raised to 1 by 2, this fourth one, and 8 raised to 1 by 0. 8 raised to 1 by 2. See children, in the previous first question only I discussed it. Powers are same, is it? But the bases are different. See, all the questions are different from each other. So you need to practice. If you have R.D. Sharma book, better practice some questions based on this one. Now look at this one. 7 raised to 1 by 2 into 8 raised to 1 by 2. So here the powers are same. In that case, you are going to write this way. See, I told you a by b raised to m can be written as a raised to m upon b raised to m. Is it? In the same way, if we have a raised to m into b raised to m, which can be written as ab raised to m. This way. So you are writing here this one as 7 8 56 raised to 1 by 2. So this way you are solving. All the 4 problems are different from each other. So you need the practice. So maths comes only after practice. Practice more and more. Otherwise you will get confused and you may find it difficult. So I want to see you practice this type of questions wherever you get more and more.